Hello students, this is a special series of video lessons brought to you by EduAims. In this series, we will be solving certain interesting and tricky GMAT quants problems taken from GMAT official guide. Today we have the lesson 1 in this series, and for this lesson, we have chosen a geometry problem of a medium difficulty level. This problem is taken from the official guide 2020 from the diagnostic test section, problem solving question number 5, and you can find this question on page number 60. Let's quickly go through what the question says. A closed cylindrical tank contains 36 pi cubic feet of water and is filled to half its capacity. When the tank is placed upright on its circular base on level ground, the height of the water in the tank is 4 feet. When the tank is placed on its side on level ground, what is the height in feet of the surface of the water above the ground? And we have 5 answer choices. Now, normally on the problem solving questions on the GMAT, you'll get 5 answer choices. Remember, just one of them is correct. And in order to find out which one of these answer choices is correct, we need to go ahead and solve this problem. So before we solve this problem, I have a piece of advice for you. Whenever you encounter a geometry problem on the GMAT, I strongly advise you to go ahead and draw the diagram, because the diagram is going to give you a spatial understanding of the problem, and this in many cases will play a very important role in helping you solve the problem. So let's see what information is given to us in this particular case. So we have a cylindrical tank. So we have a cylindrical tank which contains 36 pi cubic feet of water, and it is filled to half its capacity. So remember, this will be an important piece of information which we'll use to solve this problem. When the tank is placed on its circular base on level ground, the height of the water in the tank is 4 feet. So let's go ahead and see how will the diagram look when the cylindrical tank is placed on its circular base. Right. So here we have the cylindrical tank where the water is filled to a level h, which means since the cylindrical tank is filled to half its capacity, the water will also be filled to half the height of the cylindrical tank. Whether it is on its circular base or it is lying on its side, the water will fill half the height of the cylindrical tank. Now, this height they have already given out here as 4 feet. So this particular height, h, is 4 feet, right? And this is filled with water. So let's draw some water here. So this tank is filled with water, and since it is half filled, remember that the height of the water in this tank will be half the height of this circular tank. Okay, now what we need to do is use the volume formula of a cylinder in order to find out the radius of this circular base, right? We already have the height. So if you remember, what is the formula for volume of a cylinder? That is pi r squared h. So obviously, since the water is in the cylinder, it takes the shape of the cylinder. So we can use the formula for the volume of a cylinder to equate that to the volume of the water. So we have here the volume of the water is pi r squared into h, which is the height. So in this case, the volume of the water will be equal to pi a squared h, where the h is the height of the water, which is given as 4 feet, and a is the radius of the circular base. So a is this particular radius. Now, we can write this as 36 pi is equal to pi a squared 4. It's already given in the problem that the volume of the water which is filled in the cylindrical tank is 36 pi. And we equate that with pi a squared 4, because the height of the water is 4 feet, right? So this gives us a square is equal to 36 pi by 4 pi. So here pi and pi will cancel. So you can see here pi and pi will cancel, and 4 goes into 36 9 times. So here we have a square is equal to 9, or the radius square is equal to 9. So we can just take the square root of 9, which will give us the radius of the circular base. And we only take the positive root because the radius cannot be a negative value. It's a distance. So distance cannot have a negative value. So the radius of the circular base is equal to 3. Now, what does the second part of the problem ask you? So it says when the tank is placed on its side, what is the height of the surface of the water? So let's place, so suppose this is how the cylindrical tank is going to look when it is placed on its side. Now, since the cylindrical tank is filled to half its capacity, right? The radius of the circular base should be equal to the height of the water when it is placed on its side. So when the cylindrical tank is placed on its side, the water level will be equal to the radius of the circular base. So if I draw the water here, so this part is filled with water. So remember, the volume of the water is half the volume of the cylinder. So it's going to fill up half this entire height, and this entire height will be the diameter of the circular base. So obviously half the height would be the radius of the circular base. So the water level, or the height of the surface of the water above the ground when the cylindrical tank is placed on its side, is going to be equal to the radius of the circular base, which we've already found out to be equal to 3, right? So that should be your answer. Right. So the height of the surface of the water above the ground when the cylindrical tank is placed on its side is going to be equal to the radius of the circular base, which we've already found out to be 3. So thus we can say that the height of the surface of the water above the ground, that is what the problem asks you to find out, is 3 feet. All right. Let's clear our drawings, which we just made, and let's go to the answer choices. So you see option B is 3. So this should be the correct answer. So we'll choose this as the correct answer in the GMAT examination, right? Okay. So this lesson was brought to you by EduAims. If you have any questions regarding this particular video, you can contact us on the information which is given on your screen. If you are practicing for the GMAT and you want us to solve any particular GMAT problem, please do write to us, or you can also call us on the numbers given on your screen. Thank you for watching this video.